Welcome to one of the important topics of the block cipher, the block cipher modes of operation. As usual, let's start the session with the outcomes. Upon the completion of the session, the learner will be able to outcome number 1. Understand the need for block cipher modes of operation. Outcome number 2, we will know how does the block cipher work in real time. And outcome number 3, we will know the various block cipher modes of operation. Before knowing what are all the various block cipher modes of operation, we want to understand why do we need this concept when there are some block ciphers like DES or AES or any other block cipher. So firstly, we will understand why there is a need for block cipher modes of operation. So far we have seen two important block ciphers, the DES and the AES. Why we are calling these as block ciphers? Because they work on block, where each input block is of 128 bits in case of AES, 64 bits in case of DES. So we are clear that they are block ciphers. Say for example, we want to do some encryption for our plain text. If the plain text is computer, just calculate how many bytes it is. If every character is taking 1 byte, obviously we have 8 characters, so 8 bytes. 8 bytes means obviously 64 bits. Suppose we want to encrypt this particular plain text using DES. It's easy because DES takes 64 bits input, obviously we have 64 bits here. If you want to perform the encryption for the same plain text using AES also, it's not an issue. Because we have 64 bits here and AES takes 128 bits, you can append 0 so that you can construct 128 bits of data. So this is perfectly okay. Think if the plain text is larger enough, so when you have a lengthy message to be encrypted, or when you have an image file as an input where you need to encrypt this particular image file, or you may have a multimedia file to be encrypted. This multimedia file may be containing an image or an audio clip or a video clip or text or animations, whatever it is. Sometimes you need to work on the real-time data which needs to be encrypted. So obviously when we have a larger text or a big plain text, so obviously we need to have modes of operation. It's not simply the block cipher is doing the complete encryption in real time. In real time, we need the modes of operation where these modes of operations are working on the block ciphers like DES or AES or other block ciphers. We have now understood what is the need for having modes of operation. Let's understand this formally as well. So it's clear that we are not going to run just an encryption algorithm, rather we are going to have the modes of operation. So it's clear that we don't run just a cipher. A cipher means an encryption algorithm. So we are not going to run only a cipher, rather we are going to use a mode of operation. So this mode of operation is going to be working on a block cipher like DES or AES. So we are talking about block cipher, so obviously we'll be having a fixed length block. DES uses 64-bit block as the input and output, whereas AES uses 128-bit block as the input and output. Suppose we are inputting B bits input, and obviously we'll be getting B bits output. Say DES takes 64 bits input and produces 64-bit output. I mean 64-bit plain text is converted into 64-bit cipher text in DES, whereas in AES 128-bit plain text is converted into 128-bit cipher text. So obviously B bits input is converted into B bits output. But the real challenge is we cannot exactly give B bits. The length of the message may be lesser than B bits or greater than B bits. So the situation is, if the amount of the plain text to be encrypted is greater than B bits. Say for example, in case of AES, we know the input block size is 128 bits. Suppose we want to encrypt a file which is of 1 MB. So 1 MB means what? 1024 kilobytes. So 1024 kilobytes of data have to be encrypted. Here we have 1024 kilobytes of data, obviously which is greater than B bytes, which is 128 in this case. So how to handle this? So we want to break the plain text into B bits in each block, because that encryption algorithm is going to take B bits input. For example, AES takes 128 bits input, here B is equal to 128. Since we are in the need of encrypting a plain text which is greater than B bits, so obviously we need modes of operation, and there are 5 modes of operation defined by the National Institute of Standards and Technology. What are they? Let's see that shortly. So it's clear that we definitely need modes of operation. At the same time, we need to address this. Does security issue arise when multiple blocks are encrypted? Yes, we need to focus on this also. Suppose if we are breaking a plain text into multiple blocks and we are encrypting all multiple blocks, obviously we need to focus on the security concerns as well. So we need to focus on these areas also. Anyway, in the coming lectures, we are going to elaborately see all the 5 modes of operation defined by NIST. At the same time, can we have the same mode of operation for variety of applications? Certainly it is not possible. We may be having different applications. Say WhatsApp may use a different mode of operation, whereas a web application may use a different mode of operation. Other applications may use a different mode of operation. So based on the need, the mode of operation is going to be differing. We may be preferring AES as the encryption algorithm because we trust AES, which is really secured and powerful enough. But the mode of operation need not be the same for all the cases. So for different applications, we can go for different modes of operation based on the need and based on the security aspects. We are done with understanding the theoretical aspects of block cipher modes of operation. Let's now know what are all the various modes of operation. NIST defined basically 5 modes of operation. Number 1, the electronic code book, simply called as ECB. Number 2, the cipher blockchaining, which is called as CBC. Number 3, the cipher feedback mode, which is CFB. Number 4, the output feedback mode, which is OFB. And finally, the counter mode. These are the 5 modes of operation defined by NIST. And that's it, guys. I hope now you understood the need for having block cipher modes of operation. We know how does the block cipher modes of operation work in real time. And we also have come to know the 5 block cipher modes of operation. I hope the session is informative and thank you for watching.